Good, how are you?
Good. All right, now we're talking here. We got some stuff to do that's concrete. Shall we start here?
Yeah.
Okay. Classify the triangle by its sides and by measuring its angles. What kind of triangle is that?
Isosceles?
Well, I don't have a measuring device. I don't have a compass. So I can't tell whether that's isosceles or not. However, look at number 3.
Yeah.
Number 3 tells you that that side, EG, is the same as FG.
Yeah.
That's isosceles. So the fact that they don't put any two sides corresponding to one another is probably not isosceles. But what is it based on this angle Q? Excuse
I
me.
don't know.
Well, it's obtuse. Angle Q is greater than 90 degrees. That makes that an obtuse triangle. Number 3, we already decided, was isosceles. Two sides are equal. What's number 2 look like?
There's isosceles and equilateral. I don't know what the other one's called.
Okay. Let's go over some of these. Isosceles merely means two equal sides. Equilateral means three equal sides. If you have three equal sides, you also have three equal angles, each 60 degrees. So this is equilateral.
Yeah.
Isosceles just means two equal sides. However, this is neither isosceles nor equilateral, but it is the most important triangle of all, which is a right triangle. Any triangle that has a right angle, meaning a 90-degree angle, is a right triangle. That, to me, looks like a right triangle. They don't put the little square thing there, but based on the question and the other two, that looks like a right triangle.
Yeah.
Okay. Classify triangle ABC by its sides, then determine whether it's a right triangle. Now, there's quite a bit of math involved here. Let's see, this is 9, 3 and 2, 2. So that side is not even parallel to the x-axis.
Yeah.
Now, this point over here is 2, 2. And this point here is 9, 3. What steps do we need to consider as to what kind of triangle this is, based on its sides? And then, based on angles or whatever, determine whether it's a right triangle.
I think that's an isosceles triangle.
Well, what do we need to know? We need to know these distances.
Yeah.
We need to know that distance. I'm not even going to call it x. I'm going to call it a. We need to know that distance b. And then we need to know c. And all of those will tell us what kind of triangle it is, whether it's isosceles or not. And a couple of things will tell us whether it's a right triangle or not. However, I'm not sure you've had all of this stuff. Let's talk about the length of side A. How do you get that? Distance formula.
I don't know.
The distance between 2 points.
So,
First of all, have you had the Pythagorean theorem?
I think, but I don't really remember it.
Well, let's go over it because I'm a little puzzled. I don't think you've had it yet, but it's probably the most important theorem in all of geometry. What it says is that if you have a right triangle, meaning this is 90 degrees, then a squared plus b squared equals c squared.
Yeah, I remember that.
Okay? That's called the Pythagorean theorem, and you want to remember it for sure. Well, if you consider the distance between any 2 points, let's take 2 points, right? Those 2 points right there. We'll call that 3, 4, and we'll call this 6, 1. Okay?
Okay.
Different problem, totally independent from the one we're looking at.
Alright.
If I want the distance between those 2 points, notice that that is the hypotenuse of a right triangle.
Yeah.
So the distance between 2 points is the same as the hypotenuse of that right triangle.
Okay.
If that's A and that's B, then the distance between the 2 points is the square root of A squared plus B squared, which is the formula for the hypotenuse of any right triangle. Well, notice that A is the difference in the y-coordinates. That's a y-coordinate, that's a y-coordinate, that's an x-coordinate, that's an x-coordinate. So this distance right here is one y minus the other, or in this case, 3.
Yeah.
What is B?
3.
Yeah, B is the distance between the x-coordinates, and it's also 3. So the distance between this point and this point is the same as the length of that hypotenuse, which in this case is the square root of 18. Or if I simplify that, that's 3 root 2. Okay? So you can find the distance between any 2 points that are xy coordinate points. Okay? So let's go back to this problem and let's figure out, remember they said classify it by its sides. Well, to know its sides, we need to know the lengths of A, B, and C.
Yeah.
So what is A based on what we just said? It's the square root of what? Notice
2
that,
squared.
well, no. It's the square root of, remember that A is this little triangle right there.
Yeah.
Well, hold on. It actually is the hypotenuse of this triangle.
Okay.
What is the distance from this point to that point? It's the difference in the x values squared and the difference added to the difference in y values squared. So what is that distance for A?
36.
32. 16 plus
32.
16 plus 16. And then
Yeah.
that simplifies to that. So A is 4 root 2.
Yeah.
Okay. Now let's figure out what B is. What is B?
Is it B to C?
Well, it's this point to this point. B is that side length.
Oh, yeah.
So
Right.
figure out the distance from 6, 6 to 9, 3.
Is it 3 and 3?
3 squared, 3 squared. Again, that's the square root of 18, which is also 3 root 2.
Yeah.
So B I can replace with 3 root 2. Okay. And finally, what's the distance of C?
7 and 1.
So it's 7 squared plus 1 squared. That's the square root of 50, which is 25 times 2, which is 5 root 2. So this is 5 root 2. All right. Now that we have all three sides, is that an isosceles triangle?
No.
Is it equilateral?
No.
How can we tell if it's a right triangle?
If it doesn't have a right angle?
Well, how do we tell if this is a right angle, which kind of looks like it might be?
Yeah.
The Pythagorean theorem works backwards also, meaning that if I have a triangle, and this distance is x, and this distance is y, and this distance is z, and I discover that x squared plus y squared equals z squared, that makes that a right angle. And
Yeah.
it makes that a right triangle. So, if I replace my x, y, and z with the, first of all, I'm going to reorient this triangle to make it look like this. So, one side is 3 root 2. The other side is 4 root 2. And what looks like it might be a hypotenuse is 5 root 2. Okay, you with me?
Yeah.
I've taken this triangle up here and I've rotated it so it looks like this.
Okay.
Question now is that a right triangle?
So we gotta prove that one side plus another side equals the third side?
Almost. We have to prove that one side squared
Yeah.
plus another side squared is equal to the third side squared. So let's square that. Let's square that and see if it's equal to that squared. And if it is, then this would be a right triangle. I mean, that would be a right angle, and it would make it a whole thing a right triangle.
Yeah.
So let's write 3 root 2 squared plus 4 root 2 squared. Is that equal to 5 root 2 squared? Well, what is 3 root 2 squared equal to?
No clue.
Square both terms. What's 3 squared?
9.
What's square root of 2 times square root of 2?
8.
2.
2.
In other words, square root of x times square root of x is always equal to x.
Okay.
So no matter what it is, in other words, square root of 5 times square root of 5 is equal to 5. Square root of 17 times square root of 17 is equal to 17.
Yeah.
So when you take the square root of a number and multiply it by itself, you get that number. Okay, so what is 4 root 2 squared equal to?
16, 2.
And what is 5 root 2 squared equal to?
25, and then 2.
Okay, now let's see if this is a true statement. This is 18, that's 32, that's 50. The fact that 50 equals 50 means that indeed one side squared plus another side squared was equal to the third side squared.
Yeah, so it is a right triangle.
That makes it a right triangle. Now, that was one of the harder problems we've ever done in geometry, but quite doable. I'm a little surprised it's on there. Why is it circled? What does that mean?
I don't know. I don't know why it's circled.
Okay. Maybe it's circled because it's particularly hard.
Yeah.
Perhaps. I don't know. Let's look at 5. What is the measurement of angle 1?
Is it 106?
Yeah. You probably, I'm guessing, did it the hard way, or maybe not. In other words, there's 2 ways to do that problem. You can do it like this. What's this measurement of that angle right there?
53.
No? These 2 are 53.
Yeah.
Remember, the most basic thing about triangles that you can remember is that the sum of their angles is 180.
Yeah.
Okay?
Oh, is it 74?
So, 74, exactly. And then also, these 2 angles are supplementary, meaning they also measure to 180.
Yeah.
So what is angle 1 based on that? 106.
Yeah.
But notice that's the hard way to do it, because if you can remember the formula for an exterior angle, it's equal to the sum of those 2 angles, whether they're the same or not.
Yeah.
So you just need to add those 2 angles. So let me give you another example. What's this angle 1 equal to?
60?
No. This is always equal to the measurement of the 2 other angles that it is not supplementary with.
So 120.
110.
110.
Okay. Now, do you see why that's called an exterior angle?
Yeah.
Okay. And it's always equal to the sum of the other 2 angles that it is not next to. In other words, this angle right here has to also be 70 because these are supplementary. Since this is supplementary with this, then, and this is supplementary to those 2, then this has to be equal to the sum of those 2. And based on that same exact principle, let's do number 6. It looks like you've done number 6 already, correctly. I might add.
Okay, cool.
In other words, you made this angle, that's the exterior angle, equal
Yeah.
to the sum of this plus that.
Yeah.
Okay, let's make sure you solved it correctly. We have 8x minus 5 equals 40 plus 5x plus 15. Let's see, if we gather our x's together, we got 3x equals 60, x equals 20, which is what you had. Well, you didn't get all the way to the x equals 20, but you got 90% of it solved. In other words, once you solve for x equal 20, now what is the measurement of that exterior angle? Once I know that x is 20.
160?
Well, it's 8x minus 5. What is that when x is 20?
100, is it 155?
Yes.
Alright.
Alright, let's look at number 7 here. In a right triangle, the measure of one acute angle is twice the sum of the measure of the other angle and 30. Find the measure of each acute angle. Alright. This is basically a word problem that we have to translate into an equation. So, here's the right triangle. They're saying every right triangle has two acute angles. The two angles that aren't the right angle are both acute. And furthermore, they add to 90. Because all three have to add to 180. So if this one's 90, then these two always have to add to 90.
Yeah.
So they're complementary.
Okay.
Okay? Now, one acute angle is twice the sum of the measure of the other angle and 30. Well, let's start out by letting one angle equal x. Okay? Well, in fact, as with most word problems, the best way to start out is let x equal the smallest acute angle, which is the way I've labeled it here and drawn it. Now, from the first sentence, give me an equation that I can write.
Okay.
What is the measurement of that angle right there, based on the first sentence? We'll call that y.
One acute angle is twice the sum of the measure of the other angle and 30.
Okay, so this is the acute angle they're talking about. One acute angle is means equals, twice means 2. What's the sum of the other angle and 30? How can I write that?
60 plus 30?
No, the other angle is x.
Oh, x plus
Plus
30?
30. Okay? So they're saying that y, this angle right here that I've circled, is equal to 2x plus 60.
Okay.
Well, what else do I know? I also know that the two acute angles add to 90 degrees.
Yeah.
They're always complementary, remember.
Yeah.
Well, now I can solve for x, because I know what y is in terms of x. So all I have to do is substitute this whole thing in for that y. So I get x plus 2x plus 60 equals 90. 3x plus 60 equals 90. Solve that, you get x equal 10.
Okay.
So, the answer to our question then is we had a right triangle. We just solved for this angle, which we said is 10.
Yeah.
And the other angle is twice 10 plus 30. Well, 10 plus 30 is 40. Twice that is 80. That works.
Okay.
It satisfies every premise of this question. 80
Yeah.
is twice 10 plus 30. And 80 plus 10 adds to 90, meaning they're complementary. So find the measure of each acute angle. One is 10, one is 80. All right?
Yeah, okay.
These problems are a little harder than we're used to. Where'd we get these problems from?
My book.
Okay.
My textbook.
Okay. This is good. This is good stuff. This is what we want every single week. Stuff like this. Okay? Because this tells me exactly what you're going over. And it allows me to focus on that, as opposed to where I've kind of been in the dark on some of these sessions. All right, let's look at number 1. Identify all pairs of congruent corresponding parts, then write another congruence statement for the polygons. Well, one says that this triangle is congruent to this triangle. And we can see that all three angles are equal. Does that necessarily make them congruent?
Yeah, it does.
No, it doesn't.
Oh.
I'm going to draw a triangle that has 60, 60, 60. And I'm going to draw another triangle that has 60, 60, 60. These are not congruent, right?
Yeah.
However, if you tell me that these two triangles are congruent, now I know that all three angles have to be equal to one another, first of all. And what else do I know? If this triangle is congruent to this triangle, not only does each angle have to be equal, but what else?
The sides?
Yes. So tell me the other, she only needs one other congruency statement. So let's find a side that is equal to the side of the other triangle. Which side is it?
Is it RQ? RQ and PQ?
Find an angle and find its opposite side. This is kind of a critical part of geometry, being able to do this little thing here. In other words, let's look at PR.
Okay.
PR is opposite angle Q. Do you see why?
Yeah.
Okay. Well, angle Q is the same as angle T, based on the double marks. So the side that is opposite angle T is the corresponding side that is opposite angle Q. So PR is congruent with what? What's opposite angle T?
US.
Yes. And that's a huge part of geometry, is that the side opposite the equal angles are also equal if the two triangles are congruent. We only know they're congruent because they tell us that it is. So if I wanted another congruent statement, I could say, well, the side opposite angle R is equal to the side opposite angle U. So what would that be? What's the side opposite angle R?
P.
The side.
No.
The side.
PQ.
Yeah. Line PQ is congruent with what? The other
ST.
Yes. That is a huge principle of triangles. Not only that, but the longest side of a triangle has to be opposite the biggest angle. The smallest, let's make this 40, let's make this 50, and that makes this 90. Okay? What's the biggest side of this triangle? I'm going to label them X, Y, and Z. So Z is the biggest because it's opposite the biggest angle.
Yeah.
Which is bigger between X and Y?
Y.
That side is bigger than this side.
Yeah.
Just remember that. The biggest side of a triangle is always opposite its biggest angle. The smallest side is always opposite the smallest angle. The medium side is always opposite the medium angle.
Okay.
Okay, now this is not a triangle, but it's a quadrilateral, meaning it's 4 sides instead of 3. But everything else is the same. All the principles are the same. The biggest angle, the biggest side is opposite the biggest angle, and so forth and so on. The only thing is, in a quadrilateral, you really don't have a side opposite one angle. In other words, side DC is opposite A and B, right?
Yeah.
Okay, so what is the equivalent side to CD in this triangle here?
HG.
Okay, so give me a congruency statement I can make.
CD is congruent to side HG.
Exactly.
Okay.
Okay, and with quadrilaterals, you're always looking at a side opposite 2 angles. So side BC would be opposite A and D. So if I was looking for the corresponding side BC, which would it be over here?
GF.
Good. Okay, here we need to find the values of X and Y, and we know the triangles are congruent, because that's what it says there. And they tell us which is the congruent side. Based on the hash marks, they also tell us that that's equal to that. What kind of triangle is that?
Isosceles.
Okay. What kind of triangle is this based on those 2 hash marks?
Isosceles.
Okay. Let me draw this right one in a slightly different orientation. They're telling us that that's 30.
Okay.
Now, here's the thing about isosceles triangles. If they have equal sides, then the angles opposite those sides also have to be equal. So if this is 30, this has to be 30.
Yeah.
What is this angle? T.
120.
Good. Okay. So now let's look at this triangle over here, and I'm going to draw it in the same orientation. This is Z. This is X. This is Y. And they've told me that this is 2x minus 20. But they've also told me these two triangles are congruent. So what is Z?
90.
No, look.
Oh, 120.
Okay. In fact, what is 2x minus 20 equal to? Look at the two triangles. They're congruent.
Okay, 40.
Is that angle? These triangles are congruent. That means this angle is equal to that angle, and this angle is equal to not only this angle, but also this angle up here.
Alright.
So this one over here is 30 for sure.
Alright.
2x minus 20 is equal to 30. You solve that algebraically, you get x equal 25. Plug that in, you get a 30-degree angle right there. But the problem said solve for x and solve for y. So we just solved for x. X is 25. And we know that y, this distance here, 3y plus 9 is equal to what? Look at the two triangles. Do we have a measurement on that side? Anywhere?
Yeah, 30.
Not 30. That's a measurement of an angle. We're talking about the measurement of a side.
Oh. Then no.
Oh, what's that right there? That's the measurement of XZ.
Okay.
So if that's 15, what is 3y plus 9 equal to?
53.
15.
Oh.
In other words, this side, TS,
Yeah.
is the same side as XZ. That's it's one of the isosceles sides that are the same. In other words, XZ is the same as ZY, which is the same as RT, which is the same as TS. Be sure to distinguish between the angles and the sides, because that's what you're going to be doing for quite a while now, is talking about angles and sides of triangles. One is in degrees, the other is in whatever, centimeters or feet or inches or whatever. But the fact that these two triangles are congruent tells me that all their angles are equal and that all their sides are equal, all their corresponding sides are equal. So if 3y plus 9 equals 15, solve that equation for y.
So 3y plus 9 equals 15. So is it 45 plus 9?
Hold on. Let's go back. Algebra is extremely critical to geometry. You're going to find that you're doing algebra as much as you're doing geometry. So if your algebra skills are weak, we need to go back over them. Solve this for y. What's the first step? This is now strictly an algebra problem.
Oh, alright. Minus 9 on each side.
Okay, so what's that leave?
3y equals 7. 6.
Okay, what's y equal?
And then divided by 2, y equals 2.
So now we've solved for x and y.
Okay.
Okay? Here, before we go on, I want to show you something that I discovered online that I think would be quite helpful to you. Let's see. It's called aplusmath.com.
Okay.
And what it's going to do is test your arithmetic skills. So I want you to give me the answer as quick as you can without a calculator.
Alright. 2.
No.
9 minus -7.
Let's figure out how we're going to do this. You're not the only one that has problems with this. The reason I've been looking for so long online for this program is that I've had a terrible time finding flashcards that include negative numbers. Most flashcards don't include negative numbers, and yet the problems that everybody has are with negative numbers. So if I have 9 minus a -7, that's what that problem says.
Okay.
The two minuses turn into a plus. That's the same as 9 plus 7, 16.
Okay.
Okay? It's this one. -7 times 10.
-70.
What's this one?
-1. -36.
Good.
-27.
Hold on. My speaker just fell off my desk. Okay. What we have here, again, is a -3 minus a -9.
Okay. Doesn't that...
First of all, what does that
Does
do?
that make it a positive?
Yeah, in other words, let's rewrite it as -3 plus 9. Now what is that?
27. Wait, no.
Not multiplying.
Yeah, 12.
We got a negative. If it was 3 plus 9, it would be 12.
6.
Okay, positive 6. This is division.
Oh God.
It's a whole number answer.
Okay.
Well, I don't expect you to know this, to be honest. I don't expect anybody to know this.
Is it 8?
It's not. But this is 2 digits divided, or 3 digits divided by 2 digits. Nobody is expected to know that. This shouldn't really be on there. But the answer, the reason it's on there is they want to make sure you know that a negative number divided by a negative number is positive.
Yeah.
Go ahead.
-3. Positive 3. 1.
Negative into a positive is what?
Negative.
Remember that, hold on a moment. Here's what we have. Plus plus a plus is a plus. Okay?
Yeah.
Minus plus a minus is a minus.
Alright.
Plus times a minus is what?
A minus.
Plus divided by a minus is what?
A minus.
All right. Those are the important 4 rules. What is plus a minus?
A minus.
It depends. That was a trick question because it depends on the size of the numbers. In other words, if I had a plus 6 plus a minus 5, what is that?
A 1, positive 1.
Okay, but if I had a plus 5 and a minus 6, what is that?
Negative 1.
Okay, so a plus and a minus depends on the size of the numbers.
Okay.
So that's not always the same, but the first 4 rules are always the same. Let's not go there yet. I want to continue here just a little bit. What's this?
5. Negative 40. Negative, wait, positive 2. Negative 4. 1.
Alright, now what this problem is, it's hard to really see what it is, but it's a negative 8 minus a positive 8. That's what it is right there. Okay? How do we do subtraction problems? Now, first of all, let's talk about this problem. Why does this give people difficulties? Well, it's because that's a dash sign and that's a dash sign, but they each mean something different. This means a negative sign, okay? That's a negative sign. That means a negative 8.
Yeah.
Well, that doesn't mean a negative. That means subtraction. What I'm really doing is I have a negative 8 subtracting a positive 8.
Yeah.
Okay? Well, what I tell everybody to do with subtraction problems is turn them into addition problems. Well, you turn them into addition problems by changing the subtraction sign to an add and changing the sign on the number that was being subtracted.
Okay.
Now what's the answer?
0.
Negative 8 plus a negative 8. Negative plus negative?
Oh, negative 16.
Yeah. Once you turn it into an addition problem, it really becomes pretty easy. It's only tough when it's a subtraction problem. That?
Oh, negative 6.
7.
7.
These are the tough multiplication tables, the 7s, 8s, and 9s.
Yeah.
However, the 9s are not as tough as people think.
There's like a little trick to it, I'm pretty sure.
There is, and that's what I was about to show you. Notice that every answer adds up to 9.
Yeah.
And in fact, every answer, if I started the answer with 1 less than this, and made sure the other number adds up to 9, there's your 9s tables right there.
Yeah.
And guess what? It applies to all numbers. 9 times 123, whatever that is, the numbers will add up to 9.
Yeah.
That's a pretty cool trick. Because for one thing, it tells you if a number is divisible by 9. If I am looking at numbers and I want to know whether something is divisible by 9, well, these add up to 9. Therefore, it is divisible by 9. Is this divisible by 9?
Yes.
Because it adds to 9.
Yeah.
9 goes into that 12 times. So no matter what number I give you, if I give you this strange number like 702, is that divisible by 9?
Yeah.
Yeah, that's a cool thing to know, if a number is divisible by 9. And it also helps you with your 9s tables.
Yeah.
In other words, if you're ever questioning your 9s tables, then know instantly that the thing has to be add to 9. So what's this?
-1.
Now this may seem basic to you, but trust me, this is the best thing we could be doing
Okay,
for your geometry class, or for your algebra class, or for next year's algebra class, or for the pre-calc class that follows that. This stuff right here is the most basic fundamental math knowledge you need. And you need to be able to do it without a calculator.
alright.
What's this one?
-16. -36. -12. -5. Wait, +5.
Positive 5. In other words, what you do when you add a positive number to a negative number, hold on, now my computer's acting up. Alright, if I have a -2 added to a +7, whenever you add a negative number to a positive number, you actually subtract the two numbers, 7 minus 2, so I get a 5, and then I put the sign up of the bigger number. Well, 7's bigger than 2, so I'm going to put the plus side there. If it was the reverse, I'm still adding a negative number to a positive number, so I'm going to subtract the two numbers. But now the bigger number is 7, and it has a negative sign. That's where that goes. Okay?
Okay.
So this is +5. What's 5 and 4 add to?
9.
That means 54. 9 has to be one of the factors of 54.
Yeah. -9.
Okay?
-70. -14.
All right. That's not bad. I'm going to copy and paste this into the chat window on GoToMeeting.
Alright.
There it is. Click on that in the chat window.
Okay. Okay.
Save it in your favorites, the aplusmath.com flashcards. Save that in your favorites. And, you know, I can't force you to practice this, nor can your mom, but I'm going to tell you that if you spend 5 minutes a night doing these, it would be dramatic improvements on your math scores.
Okay.
And you might not see why at first glance, but trust me.
Alright.
It'll make all the difference in the world. I find that at least half of my students that have problems in algebra or geometry, their problem stems from the fact that they never fully memorized their math properties. Their addition, subtraction, multiplication, and division of positive and negative numbers. That's the key. All right, let's go back. We got 5 minutes. Let's do one more, number 4. So again, this quadrilateral is equal to this quadrilateral, or congruent, excuse me. So, can you figure out the corresponding angles and the corresponding sides? What is angle G equal to?
Angle G is equal to angle C.
Okay. So I can write 8y minus 3x is equal to 62.
Okay.
about angle A? What does angle A equal to?
E.
So tell me what I can write.
60 plus 8x equals 108.
Okay. All by itself, can I solve that for x? Just tell me yes or no.
Yeah.
All by itself, can I solve this for x and y?
Yeah.
No.
No.
You cannot solve one equation in two variables if that's all you have.
Okay.
There are basically an infinite number of solutions for this. But here's the key. This equation here does allow me to solve for x because there's only one variable. So let's solve this one for x. Give me the next line.
Minus 60. So 8x equals, no, 48.
Always remember that after you've done the subtraction, that number plus that number has to equal that number.
Yeah.
And that's a good little test to do, to make sure you subtracted them properly. Okay? Besides that, it's pretty easy to add that number to that number. And yes, it equals 108. So what does x equal?
X equals, 7.
6.
6.
You need to memorize your 6, 7, and 8 multiplication tables.
Alright.
Those are the toughest for most. The 9s are easy because of that little trick, but 6s, 7s, and 8s are pure memory.
Alright.
Okay? Spend 5 minutes a day on A+ math and you'll have it memorized in no time.
Okay.
Okay? So, now we have solved for x. Okay? And that's the same x as up here. So
Alright.
the fact that I now know that x is 6, well, I can plug it in. Then I will be able to solve for y. Notice now we don't have two variables anymore. We only have one variable, y. One equation, one variable, you can always solve for that. So help me solve this.
Alright, so minus 18.
Okay.
So 8y minus 18 equals 62.
Okay. Next line.
Plus 18.
Okay. So 8y equals what?
80.
Okay. Y equals?
10.
So y equals 10, x equals 6. We got our solution. We're done.
Alright.
All right. Julian, I think we have discovered a lot tonight.
Yeah.
I really do. And I swear to you that if you spend, or we'll spend 5 minutes a night on that A+ math until I am convinced you know them perfectly every time.
Okay.
Here's why it's important to know them perfectly. If you only know them with 95% accuracy, here's what's going to happen. You're going to go to take a test one day and you're going to say, well, I can either rely on my memory or I can rely on this calculator. Which one do you think you're going to choose?
The calculator.
Exactly. That's what everybody does. And guess what?
Yeah.
After a while, their 95% proficiency drops to 90 and then maybe 80. And after a while, they don't remember nothing.
Yeah.
So the calculator is a great benefit to mankind, but it's also a big detriment to people's memorizing their multiplication tables.
Yeah.
After a while, you forget it. I used to be able to play the piano beautifully 10 years ago, but I haven't had a piano in 10 years. I cannot play a note. If you gave me a piano and set me down at a piano and said, play the first 3 notes of any song you've ever known, I wouldn't be able to do it. That's how much you forget stuff when you don't practice it. Same thing about multiplication and division and addition and subtraction of positive and negative numbers, is you need to keep doing it in order to stay good at it.
Yeah.
The calculator is just no substitute. I mean, I don't know if you figured it out by now, but whenever we're solving these equations, you can't use a calculator. There's like 6 different calculations that need to be done. I just can't use a calculator for every one of them. I've got to be able to do single-digit calculations. So I'm convinced that once you've discovered that you're good at single-digit calculations, and I don't think you're that bad at it, you're relatively good. You just need to increase your accuracy a little bit. Once you do that, it's going to change everything for you.
Okay.
Okay?
Alright.
All right, Julian. I'll talk to you next time.
Okay, thank you.
Bye-bye.